Building an airport on the ocean sounds impossible, right? But Japan did just that, creating Kansai International Airport, a $20 billion engineering marvel that defies the limits of technology and physics. It was groundbreaking, revolutionary, and aimed to solve Osaka's airport problem in the most audacious way possible. Fast forward decades later, and despite its monumental cost and effort, the floating airport is sinking faster than anyone expected. And now, no one can figure out how to fix it. So, why is this $20 billion marvel still struggling? And is there any hope of saving it? Let's find out. Osaka is Japan's second largest city, behind Tokyo, and the economic and cultural hub of the Kansai region. It is also known for its rich local culture, delicious food, particularly street food like takoyaki and okonomiyaki, and historical significance. Osaka's ambiance is more relaxed and friendly than Tokyo's busy and fast-paced way of life. It features traditional areas like Dotonbori and attractions like Osaka Castle, mixing modern urban life with a rich past. The Kansai International Airport is located on the Bay of Osaka on an artificial island. This airport began its operations in 1994. This airport was celebrated as the world's first airport built on reclaimed ocean land. The airport was created to meet the demand during Japan's post-war economic boom, which saw the country rise to become the world's second-largest economy in 1968. Engineers came up with the bold idea to construct an airport offshore in Osaka Bay, when the city's previous airport was overloaded with passengers and freight due to the surrounding mountains and a lack of land for growth. Being a massive project, the Kansai International Airport took decades to plan and years to complete. The engineers struggled with the technicalities of constructing an airport which is completely offshore in the ocean throughout the first 20 years of development, which started in the 1960s. When the plans were finished in 1987, construction began, and it took 7 years to complete. At the time, the project was estimated to have cost $4 billion, or around $40 billion now that inflation has been included in. The project's highlight was the 3.7-kilometer-long Skygate Bridge R, which connects the airport to the mainland. Because of the site's fragile geology, building the foundation for Kansai International Airport in Osaka Bay was extremely difficult. Along with sand pockets that made stability even more difficult, the seafloor was composed of Holocene clay, a soft, water-saturated soil that is prone to compression. The seabed was compared by engineers to a sponge because it is extremely porous, prone to water retention, and deforms significantly under pressure. This analogy showed the challenge in establishing a stable foundation for the huge infrastructure required for an airport. More than 1 million sand drains were buried in the sea to solve these problems. These served as channels for the clay's water to be released, speeding up the soil's condensation and giving the man-made islands a more stable base. The man-made island required a great amount of labor and materials to develop. An astounding 180 million cubic meters of earth, roughly 75 times the volume of the Great Pyramid of Giza, were used by engineers to build the island. To create the island's foundation, this material was carefully positioned after being delivered by a fleet of ships from several quarries. This massive project comprised more than 10,000 individuals who put in a total of 10 million hours over 3 years. When engineers created Kansai International Airport, they anticipated that the artificial island would eventually sink into the soft ocean floor. They estimated that it would settle by roughly 8 meters over 50 years, which is a reasonable amount within their predetermined limits. But the truth proved to be much more dramatic. The island had already sunk 12 meters by the time the airport opened in 1994, which was much deeper than anticipated. To handle this situation, engineers needed to move fast to keep the island from sinking below the essential height of 4 meters above sea level, which would expose the airport to flooding and operating risks. An additional $100 million was spent to raise the island by 4 meters. In order to stabilize the settlement, this required raising the runways and terminal areas, strengthening the foundations, and adding layers. Before we move on, I'd like to ask you a small favor. If you like this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. Imagine what we could accomplish if everyone subscribed. It costs you nothing, but it makes a huge difference to us. So, is it done? Great, thank you so much. The terminal of Kansai International Airport, designed by renowned architect Renzo Piano, is among the most remarkable achievements of airport architecture. At 1.7 kilometers, it was the longest terminal structure in the world when it was built. In addition to showcasing architectural splendor, the huge building used state-of-the-art engineering and innovative functionality to address the particular difficulties faced by the airport. The terminal's most prominent feature is its wave-like roof, which was created with both beauty and practicality in mind. The roof's undulating shape is more than just an architectural statement. It also serves an important role in maximizing airflow throughout the structure. By eliminating the need for heavy air conditioning, this natural ventilation system improves the terminal's energy efficiency and passenger comfort. Osaka, which is located in a seismically active zone, requires the terminal to contain cutting-edge earthquake-resistant equipment. In order to protect passengers and reduce structural damage in the event of an earthquake, the terminal's framework was made to bend and absorb seismic shocks. Specially designed joints and materials enable the building to move with the earthquakes instead of resisting them, giving it this flexibility. The airport survived the Great Hanshin earthquake in January 1995, which destroyed several surrounding districts. The adoption of sliding joints and seismic-resistant technologies in terminal buildings and other structures reduced damage and kept operations running smoothly. One of the more unique parts of the terminal's design was the installation of 900 hydraulic jacks beneath the structure. These jacks are essential because they allow the terminal's height to be continuously adjusted in response to the earth underneath it lowering. The jacks may raise or lower portions of the terminal to maintain its level and functionality as Kansai's man-made island settles over time. Despite the continuous difficulties brought on by the sinking of the first artificial island, the Kansai Airport would be able to keep its status as one of the busiest airports in the area, thanks to the new island's capacity to accommodate more runways and terminals. In 2001, Kansai International Airport received the Monument of the Millennium Award from the American Society of Civil Engineers in honor of its historic construction and groundbreaking accomplishments. With this esteemed accolade, the Kansai Airport joins some of the most famous and technically difficult infrastructure projects in history, including the Golden Gate Bridge and the Hoover Dam. This award recognizes projects that have had a transformative impact on civil engineering while demonstrating extraordinary ingenuity and resilience. By overcoming obstacles including sinking ground and seismic activity, the Kansai International Airport was able to construct a huge airport on an artificial island, solidifying its position in history. One of the hardest problems engineers have yet to completely resolve is the sinking of Kansai International Airport. According to experts, the airport would reach sea level by 2056 as a result of continuous subsidence. The original island will soon be buried since the ground beneath the airport is sinking at a rate of roughly 7 centimeters each year. Despite efforts to delay the process, such as the extensive use of hydraulic jacks to lift the terminal and the erection of seawalls, sinking is unavoidable when built on such an unstable surface. To deal with the constant sinking, the Kansai International Airport has undergone continuous reinforcement and adaptation. Originally constructed to shield the airport from storm surges and rising tides, seawalls are frequently raised and fortified to take into consideration both the sinking of the land and the rising sea levels caused by climate change. Although these changes have been crucial in averting more severe damage right away, the airport will still settle, so it's a continuous process. Now that you've learned about Kansai International Airport's great challenges, creative solutions, and ongoing struggle with sinking, we'd like to hear your thoughts. Do you think the airport will eventually hit its limit? Or do you think engineers will discover a solution to prevent the sinking in the future? How would you make things better? Post your suggestions and opinions in the comment section below.